In this video, I'm going to go over how to write a double replacement reaction and basically predict the products. So whenever you have a double replacement reaction, you're going to have two ionic compounds. And usually these double replacement reactions will happen in solutions. So you'll start off with two aqueous solutions and put them together. So when you have these two ionic compounds and they react, basically the cation, which is a positive ion, will switch places. So at the end, when I figure out your products, one of these products has to be insoluble for the reaction to actually happen. So when you're predicting products, what you're going to do is you're going to switch the cations. You're not going to carry the subscripts over. You have to check charges and make the formula based on that. And then one of your products has to be insoluble. So let's look at this one. All right, so for this one, I have potassium, so I'm going to identify my cation first. My cation is going to be either my metal or ammonium, and then in this case, my cation is going to be magnesium. Now, potassium will switch places with magnesium, and magnesium will switch places with the potassium. So once you have identified your cations, you are going to look at the charges. So potassium has a +1. Well, when it switches with the magnesium, it's now going to bond with Br. So I need to look at the charges. Bromine has a -1 charge. So when I write this as my first product, it's going to be Kbr. So I'm not carrying this 2 to the other side. I have to check the charges and switch. So now magnesium will bond with the other anion. So remember, magnesium cannot bond with potassium. You can't have the positive with the positive. And right here, magnesium is already bonding to bromine, so the only other option would be hydroxide. So it's going to bond with the hydroxide. So when I make my products, it should be Mg, and then this has a +2 and a -1 charge. It should be MgOH parentheses 2. So that's what my next product should be. So afterwards, I have to make sure it's balanced. I have 2 bromines here and 1 here. So I'm going to have a 2 there. And then now I have to fix the potassiums. So it's 2 potassiums if I put a 2 there, and then also 2 hydroxides, which fixes that too. So those will be my products. So right now, we're not going to check to see which one is insoluble. We're going to just practice with predicting the products right now. All right, so now we have barium sulfide plus nickel sulfate. So what we do is we identify the cations first. So it's the metal in this case, so barium, and then nickel in this case. So we need to look at the charges. Barium's a +2. We had sulfur over here, that's a -2. So I'm just going to pull all my ionic compounds apart and then just look at the charges. All right, so nickel. Nickel is a transition metal. It can have more than one charge, so I need to figure out what the charge is. So SO4 is a -2 charge, so that means that if I've only got one nickel atom, each one has to be a +2 because we need that to cancel out the -2 in the sulfate. All right, so now the barium will switch places with the nickel, so it'll go here, and then it's going to bond with the sulfate. So remember, you can't put a positive with a positive, so barium cannot bond with nickel, and it's already bonding to sulfur here, so the only other option would be sulfate. So it's going to be barium with a +2 and sulfate with a -2. So that's just going to be one of each. So you're not pulling subscripts over, you have to check your charges. All right, so now nickel is going to switch places. So nickel is bonding to sulfate here, so it can't bond to sulfate on the other side, and it definitely can't bond to the positive ion, so the only other option would be sulfide. So it's going to be nickel to sulfide. So nickel with a +2, sulfur with a -2, they cancel, so it's just one of each. All right, so now I've got my 2 products. And let's see if we're balanced, and it just happens that it's already balanced. All right, so let's look at the next one. All right, so in the next one, I'm going to identify my cation. In this case, it's ammonium, so it's either going to be a metal or ammonium. And then in this case, it's the metal, which is zinc. So ammonium has a +1 charge, sulfate has a -2 charge, zinc is always +2, and chlorine is -1. All right, so now ammonium will switch places with the zinc. So ammonium cannot bond with zinc because it's positive, and it's already bonding to sulfate here, so it won't bond with that. So that's out, that's out. The only other option is chlorine. So it's going to bond with chlorine. All right, so +1, -1, they cancel. So it's ammonium chloride. All right, now we're going to look at zinc. Zinc will replace ammonium. So zinc is already bonding to chlorine, so that's out. That's not an option. And it cannot bond to ammonium because it's positive, so the only other option would be the sulfate. So it's going to be zinc with a +2 and sulfate with a -2. They cancel, so it's just one of each. All right, so now we need to balance. Ammonium has 2 here, so let's put a 2 there. Let's see if what else we need to fix. And also chlorine has 2 over here, so we have 2 over there. We've got 1 sulfate, 1 sulfate, 1 zinc, so we're balanced at this point. And I advise that you, if you're struggling with this, maybe try one on your own, and then, so pause the video, and then watch me do it. All right, so let's look at this one. Identify your cation, aluminum, and then lithium, so the metals. Look at the charges. Aluminum's +3, chlorine is -1, lithium is +1, and hydroxide is -1. All right, so now aluminum will replace the lithium. So aluminum will now bond with hydroxide because it can't bond with lithium. It's already bonding to chlorine here, so it has to bond to hydroxide. Aluminum's +3, hydroxide's -1, so the formula should be this. All right, so now lithium will bond, let's see, well, it's not going to bond to hydroxide, it's already bonding to that. It can't bond to aluminum, so the only other option would be chlorine. So it would be LiCl. All right, so let's see if we're balanced. Got 3 hydroxides here and none here, so I'm going to put a 3 there. And then I got to fix the lithium. So 3 lithiums, and then my chlorine is a fix now. So there's 3 here, and everything else is balanced.